Now we're going to look at how data-driven processing can lead to pattern recognition. So essentially we're going to be looking at 4 different theories that help explain how humans can look at something, whether it be a letter, a person, an animal, a building, a car, and recognize it. Know what it is. And so the 4 theories are distinctive features theory, recognition by components theory, we'll call that one RBC when the time comes, template matching theory, and prototype theory. Luckily for us, 4 names of these theories will be very helpful because they are nice descriptive names of how the theories work. So we're going to start off with distinctive features theory. This is developed by Gibson in 1969. And again, look at the name, distinctive features. And it basically says that all complex perceptual stimuli, including objects, are composed of features. Distinctive features are cues that allow observers to distinguish one object from another. So the features of a letter, for example, will include the shapes, the angles of the lines. Are there any curves in it? Which way are the lines facing? Which way are they leaning towards? Are they vertical? Are they horizontal? Are they diagonal? And so on. And so if we think of the distinctive features of the letter A, we can look here at the whole alphabet. What makes A different and unique from the other letters? And so we can think of, okay, so it has these 2 diagonal shapes, and they are together at the top and apart at the bottom, and then in the middle there's a horizontal line. And sure enough, there's no other letter in the alphabet that has that combination of 2 diagonals and a horizontal. So that might be one way that the letter A is quickly and easily identified by us according to distinctive features theory. Distinctive features theory suggests that pattern recognition is accomplished by mentally assessing the presence or absence of a checklist of these critical features. And so in the case of an animal like a zebra, it's kind of obvious what the distinctive feature is, right? The zebra's distinctive features, probably the black and white stripes that it has that definitely distinguish it from other similar types of mammals. And so that's a nice way, I think, of trying to remember distinctive features theory, is to remember the zebra and its distinctive black and white stripes and kind of connect that then to the essence of that theory. Now, when we look at a large scene around us, one thing that can easily happen is that there might be many, many possibilities for us to focus on, many different options for us to sort of focus on or look at and find the features in. So how does the mind reduce the number of possibilities so that it can concentrate on just one thing? A partial answer is that we start with global features and progress to more local ones. So let me give you an example of what I mean by global versus local. So very quick, find the letter H. Now find the letter U. For many people, the H is very quick to be identified. It's right here. We see this letter H. And when we were asked to find a U, it might take us a little bit longer because we see that there is no big U, but there is here a letter L made up of small U's. So this is a nice example of a shape or a figure that has both global and local features that can be interpreted independently. The global is the overall letter. The local are the individual letters that make up the global shape. And there is this effect called the global superiority effect, where the properties of the whole object take precedence over the properties of parts of the object. So when you look at a car, you see the whole car. You just see, the car. Before you identify the individual details of that car, for example, the particular type of rims it might have, or the particular shape of the taillights, that our first impression is of the whole of that car. So that's the global superiority effect. Is that always the case? No. But in general, people tend to notice the big picture first.